Hello. In this video, we will cover how we train the models and what we did some pre-processing steps, what we attempt that steps, and how we train the model to predict whether a payment or a credit card payment is a fraud or not. Okay. So for that, what you have to do first you have to open Anaconda Navigator. Okay. Then you just have to select a project over here. Okay, and then just after loading this environment, what you have to do, just click on this no remind me later and then click on environment. Okay, after that here you have to click and then select first option, that is a open terminal. Okay, now first of all, if your folder on a desktop is on a desktop, then what you have to do, you just have to type Jupyter hyphen notebook. Okay, and then just press enter. Okay, when you press enter, one window will pop up in your default browser. Then here you have to do one thing, that is check where is the desktop folder. You have to find out. First thing, maybe your desktop folder is in a OneDrive, so just open this OneDrive. Okay, just you have to click on this OneDrive and then here you will get desktop. Okay, so you have to open this and here you will get all the folders and like a project folder and whatever the folders and files available on your desktop. Okay, so this is how you can find out your Jupyter notebook, like this folder. So in final project you will get Jupyter files, library files, a report and paper and website. Okay, so what you have to do, you just have to open this Jupyter file and then you have to open this random forest.ipynb. Okay, so this is how you can find your folder, this Jupyter notebook folder, Jupyter files folder, if that folder is on a desktop or is on a downloads. If your project is on a downloads, then you just have to open this download and then you will get all the things. Okay, but if your folder is in another drive, that is E drive or a D drive or F drive. Okay, so at that time what you should do, then just close this, open, just come again in Anaconda Navigator, click on this, then select first terminal, and here you have to enter that drive name. Okay, name should be small or capital, not necessary. So if your project is in a D drive, then just D colon you have to enter. If your project is in a E drive, then E colon. If your project is in a F drive, then E F colon. F in H colon. Okay, this is how you can navigate to yourself. So if I enter D colon, so by default path is C. Now we will change that path, and now that path is in a D type. Here we have to type Jupyter hyphen notebook and just press enter. After pressing enter, your home page, that is a Jupyter home page, will open in that particular drive. So now you have to navigate yourself to that drive or that folder. So now we have this final project Jupyter files, and here we have random forest.ipynb. Okay, so you have to open this random forest.ipynb, and this is the CSV file. I mean, this is the data set which we used. So we fetch this data set from Kaggle. Okay, so if you want any kind of link, then you can refer this doc. We mentioned that doc over here, this reference document. So on this doc, that first link is a dataset link. Okay, so just open this. Now in this file, what we did, and what is the procedure to train the model, and like how we can train the model and all. Okay, so first of all, this is the Jupyter notebook interface. Here you will get so many options. First, that the main 3 to 4 options are run, stop, restart kernel, and this is the fast forward, in the sense run all the cells. Okay, so if I want to run this single cell, then what should I do? Like I have to select this cell and then just click on this run. Now here you will get star, and here you will get black dot. So for example, if I restart this and again if I run this cell, so on the right side here you will get dot, a black dot. Okay, in the sense your cell is in a running state. Okay, or your Jupyter notebook is in a running state. Okay, so this is how you can run a single cell. But if you want to run this cell after a third cell, then you can't run this because we stored this because we read some CSV files and we just stored that data here, and then we just print this variable over here. So without defining any variable, if you run this cell, you will get error. Like if I run this and this, then if I directly run this, so it will give me an error. Okay, name error, name, fraud data is not defined. So fraud data we defined over here. So if I run this, now it's a 8th cell. Okay, and if I run this again, it's a 9th cell. Now I got all the data again. Okay, so you have to run cell one by one. Okay, don't skip any single cell. Okay, now let's come to the main point, or that what we did in this Jupyter file. Okay, so first of all we import some libraries, that is a numpy is used to uh, manipulate the array. Okay, like if we have multiple arrays, so we can reshape that array, we can convert it into the matrix, we can convert that data types and all. Okay, or else if you have so many list or arrays, then you can manipulate via numpy. Okay, then if this pandas library is used to manipulate the CSV file in the sense Excel sheet. In Excel sheet there are uh, uh, so many extensions. Okay, like CSV is there, TSV is there, Excel is there. Okay, then through pandas we can read JSON also. Okay, so you can manipulate that JSON. Manipulation in the sense, if I want to like if I want to remove this particular column, okay, then I can use this pandas library. Okay, if I want to remove this particular row, then I can use that pandas library. So through pandas I can remove a row or a column. If some null values are there, then I can replace that null values with mean of this column or something else. Okay, or if I want to drop that multiple null values, then I can use this pandas library. Okay, so this is how you can manipulate this file, just like a MySQL database. Okay, like by using some queries we can manipulate the database and we will get the output. So through pandas you can manipulate the CSV file and you will get the data. Okay, so next is a pickle in the sense, pickle is a binary format file, so we can store any kind of data in a binary format. So if I want to train some algorithms and I want to store that, then I can use this pickle. So whenever I'm calling this pickle, that at that time I have to dump whatever the data I have. Okay, and after dumping the data, that data will store in binary format. Okay, so that's why we use this pickle. So we will train the model and we will store that model in this pickle file. Next is a HMM learn. So HMM is also another algorithm which is used to predict, or which is used to classify the data. Okay, next what we did here, like through pandas library we read this CSV file. Okay, after reading this CSV file, we stored that data in a fraud data variable. Okay, after that we use this head in the sense, by using this head, what it will do, that it will print first 5 values from this CSV. Okay, first 5 rows. If you use tail instead of head, then it will print last 5 values. Okay, and if you if you mention some values in this in this brackets, then you will get that number of rows. Like if I mention 10 and if I run this, so it will print first 10 rows. Okay, so here you will get the information like how many rows and how many columns are present over here. Okay, now what I want to do, like I want some particular columns. I don't want all these columns, like total 23 columns I don't want. Okay, so what I'll do, I'll fetch few particular columns like category, amount, gender, city, state, latitude, longitude, job, and is fraud. So these are the columns which I want, and I want to feed this column to the model, and then we will train the model based on this inputs and outputs. Okay, so we stored this column data in df in the sense data frame. Okay, it's a short name. After that we use this resampling. Why we used, because 0 in the sense not fraud and 1 in the sense fraud. Okay, so if we check this majority value is a 1,42,000. Okay, and minority value contains 6,000. In the sense, fraud data contains 6,000 and zero data contains 1 lakh. So what we want, that fraud data should be 1 lakh. Okay, if we have a one higher value and one lower value, then what we have to do, we have to balance both values. Okay, because if we feed this kind of data to the model, then model every time will give us a non-fraud output. Okay, because a fraud value is so less, that's why we have to feed balanced data to the model. Okay, so that's why we use this resample a library to balance the data. Okay, so we here we balance the data and we stored that data in my data 3. So now you will get the idea. Okay, now what we will do, we will check the count value, like how many zeros are there and how many ones, in the sense how many fraud values are there and how many non-fraud values are there. Okay, so by using this value underscore count, we can we'll get this idea. Okay, and after that we just print this my data here. So it will print first 5 and last 5 values, as well as how many rows are there and how many columns are there. Okay, now we have to check some unique values in gender, in city, state, like each column. If you want to check, then by using this line you can check like what are the unique values available in this in that particular column. Okay, so you just have to change this column name. So instead of gender, I can use this city. So if I put city over here, then it will give me all unique city values, city names here. Okay, then we use this label encoder. Label encoder is used to convert it, it will label the like for example, we have this value. Okay, these are the values we have, but now we have some values in a string format, like a category name, gender name, a city, state, and a job. These are the values available in string format, but other values are available in float as well as in a string format. Okay, so what we have to do, we have to convert whole data in in one data type. Okay, and then we have to feed this data to the model. But if we feed all string values to the model, then model can't accept, because model need some integer or float values. Okay, so that's why we have to convert this string format into a numbers, numerical value. Okay, but like in category we can check misc pos is there, misc net is there. Okay, then misc pos, again misc pos is there. Okay, grocery pos is there, grocery pos is there. Okay, so some values are repeated values. Okay, so what I have to do, like each value I have to assign some numbers. Okay, so some unique numbers I have to assign, but if I do this manually, if I manually assign some values to the 2 lakh rows, then it takes too much time. Okay, maybe 4 to 5 hours or more than that. Okay, but I want to do this work within a within a minute. Okay, so this label encoder will help. It will check what are the unique values are there, and it will assign some unique values to each category. Okay, so what we will do, like first we initialize this label encoder, then we feed that particular column to the label encoder. Okay, and we just transform that values which is available on that particular column. So we just transform that, and we just we stored that value in another column. Okay, so same thing we did for another columns. Okay, so now if I use if I convert, like right now I have one unique value, okay, 339, and I want to check what is the original value of this value, original value of this integer. Okay, so if I use this inverse transform, then it will uh, give me some value. Okay, 339 we assign to this high roll mountain city, mountain park. Then if I pass this 4, okay, level encoder 4, le4 to 4. Okay, then it will give me ca. So it show uh, it showing me that we assign four integer value to this ca. So whatever the values are available in ca values available in state, okay, that each ca value contains a fourth value, four integer value, four number, we can say. Okay, so this is how we have this is how level encoder can create the table, or level encoder can create the column. So we can check, for example, in category we have 84029 and 9. So see, here we have misc pause, and again here we have misc pause. So misc pause contains ninth value, and here misc pause contains ninth value. Okay, so this is how label encoder can label the data, label to each value. Okay, now we want some final values here, like category, gender, city, state, and job. Okay, so we just access that data, and we just store that data in one variable. After that we have to check some unique values available in label category label. Okay, then we just inverse that list, this whole list, so we'll get the original values. Okay, now here we have to split the data, like we have from this dff, uh, yeah, from this dff we have to drop this is fraud column. Okay, because this is our output, so we have to store that is fraud column in y-axis. Okay, and the remaining columns available in dff, we have to store that columns in x-axis. Okay, so these are the independent variables, and these are the dependent variables, in the sense x is not depend on y, because if I change some values in x, then y doesn't matter. Okay, sorry, y matters. Okay, because if I change some values and that value is related to a fraud, okay, then y should have to change the value from non-fraud to fraud. Okay, like I have one data which is related to non-fraud. Okay, and I change some values from this columns. Okay, like amount, latitude, and longitude. I change these columns. Then y should have to convert this 0 into 1. Okay, so y is depend on this values, but x is not depend on y. If y change, then x doesn't matter. Okay, so that's why we name it as a independent variable and dependent variable. Okay, now x contains all the columns and y contains only is fraud column. Okay, now we have to split this data. So the splitting size is 0.1, in the sense 1% we will store in test. Okay, and remaining 90% we will store in train. Okay, so in x-axis whatever the data, like all the columns we have, okay, except is fraud. So uh, in X column, out of 100%, we will store 10% data in X test and 90% data in X train. Same thing we will apply for Y. Like 90% data we will store in Y train and 10% data we will store in Y test. Okay, and this splitting the data is in a random way. Okay, after that, here we initialize this random forest classifier and we set some parameters like an estimator and all. After that, we feed this X train and Y train data to the random forest classifier, and then we train the model over here. Okay, after training the model, what we did, we just feed this X test data to the model and we got the Y pred. Okay, now this is the predicted value. Now this Y test contains some 10% values. Okay, and the output of this 10% value is available in Y test. Okay, so X test contains some values and the output of X test is available in Y test. So we have to compare. If I feed this X test and model gives me prediction, so I have to check Y pred, that predicted output and original output. I have to compare both the things. Okay, so if I compare both the things and if I feed both the values to the accuracy score, then it gives me the accuracy that is 99.59%. Okay, so the random forest accuracy is 99.59%. After getting the accuracy, we stored the data in a pickle file. So we have to mention the name of the file, and then we have to feed this model in a pickle.dump. Okay, inside, and then we have to pass this file name here, and this is the wb in the sense write in binary. So it will store the data in binary format in this file. Okay, after storing the data, we have to check whether whether data stored in a correct way or not. So for that, we read this file here, we open that file, and here we mention, and here we change the value, that is a rb in the sense read in binary. So if I run this value and if I didn't get any output, in the sense file is proper, we stored the trained model in that file successfully without any errors. Okay, so this is how we train the model, and we use this model in at the back end of our UI. Okay, so in next video we will cover how our UI will work and what is the backend, what is the front end and all. Okay, but now in this video we initially told you that what is the procedure to open the Jupyter notebook. Okay, so please follow that procedure and uh, train the model again if you want. Okay, thank you.